Hi there, and welcome to the Working with Services and Dependency Injection module from the Building Your First API with ASP.NET Core course at Pluralsight. My name is Kevin, and I'll guide you through the rest of this module. We've built our API, but we're not done yet. All APIs require a certain amount of logging, and ASP.NET Core has a built-in logging service. But to use that logging service, we must inject it into the class that needs it. So first of all, we'll learn about ASP.NET Core's built-in dependency injection system. And then we'll inject a logger through this. And we'll also learn how to log to a file. Next to built-in services like the logger, we can also create, register, and use custom services. And that's what we'll do next. We'll make sure that when a user deletes a point of interest, the administrator of the system is notified of this. We'll separate that functionality out in a custom mail service. And that also means we'll have to store the mail address to send that mail to somewhere. So that allows us to look into configuration files. Let's dive in. So let's talk about IOC, inversion of control, and dependency injection. We'll start with an example. Imagine a class that uses different services. For example, when we implement logging in the upcoming demo, our points of interest controller will use a logger service. That's a concrete type specified at design time. This means that the points of interest controller has a dependency on the logger. We typically new it up in the constructor. And let's say it also depends on one or more other services. Problems arise when you need to replace or update that logger. The controller's source code will have to change. And it also makes the controller harder to test. You can't just replace the logger with a mock version of the logger, as we're using the concrete type. And the class needs to manage the lifetime of the dependency. In short, this is tight coupling. And that's where the inversion of control pattern comes to the rescue. It delegates the function of selecting a concrete implementation type for the controller's dependencies, the logger in our example, to an external component. Okay, great, but how do we do that? And that's what the dependency injection pattern helps with. That's in fact a specialization of the inversion of control pattern. The dependency injection pattern uses an object, the container, to initialize objects and provide the required dependencies to the object. We've talked about that container before. You register services with the container, and the container is responsible for providing an instance of it to the class that needs that instance. It manages the lifetime of the dependency. Let's have a look at a code sample. So this is what it looks like. We've got a backing field to hold the dependency. But this is not a concrete implementation. We're expecting a class that implements the iLogger interface. In this example, typed to the controller. The constructor has changed as well. This is constructor injection. The constructor of our controller needs an instance of a type that implements iLogger. Again, no longer a concrete type, an interface. The container injects the dependency for our class. The net result is that our class is decoupled from that responsibility and from that concrete type. The dependencies can be replaced or updated with very few or no changes at all to the code in our class. And the class itself can easily be tested because those dependencies can be mocked by providing a mocked version of iLogger. Even though a lot of architectures in the old ASP.NET versions contained some form of dependency injection, through ninject for example, it wasn't built in. In ASP.NET Core, it is. Some services are built in and by default registered with the container, like the logger. Others can be added, and that's typically done in the configure services method of the startup class. Both framework services and our own application services can be added. In fact, we already did that in the second module when we registered the MVC framework services. Let's see how we can inject one of the built-in services, a logger, into a controller in the demo. In this demo, we'll inject the logger into the points of interest controller we previously created. The logger is a built-in service, so we don't have to add it to the container in the configure services method. What we do need to do is configure one or more loggers so the service knows what to log and where it should log to. We do that in the configure method of the startup class. An iLogger factory implementing instance is already injected, and that gives us access to the logger factory. We need to add one or more providers so it knows where to log to. The add provider method allows this, but there's shortcuts to this. Actually, we already see one on screen. Add console. This will log to the console window. What I like to do is log statements to the debug window, which is quite convenient when developing. And we can do that by calling add debug on the logger factory. Let's try that one. NuGet integration tells us we need the Microsoft.extensions.logging.debug package. So let's add that. And there we go. We can choose the minimum level we want to log to the debug window. We can choose to log only critical failures, only debug, error, information, none, trace, or warnings. Let's keep it at the default, which means information level or more serious. That's it for configuration for now. Now we need to effectively log something. So let's open our points of interest controller. We could request an iLogger factory and create a logger. But there's another way. The container can also directly provide us with an iLogger T instance. When this technique is used, the logger will automatically use the type's name as its category name. So for our points of interest controller, we'll need an iLogger points of interest controller. So let's add that field. And let's add a using statement to Microsoft.extensions.logging. Now we need to inject an instance of this. And by adding a constructor, we can use constructor injection. So the container will provide an instance through dependency injection. So let's add a constructor. And let's tell the dependency injection system we expect an iLogger points of interest controller. And there we go. Constructor injection is the preferred way of requesting dependencies. But for those cases where that's not feasible, you can always request one from the container directly. You can do that through http context.requestServices. On that, we can then call getService and pass in the type of the service we want. What this does is provide access to this HTTP requests container. But as said, it's advised to use constructor injection instead, so we'll stick to that. And then let's effectively log something. In the action that returns the points of interest for a given city, we check if the city exists. So let's log if the city isn't found. There are extension methods for each logging level. We need the log information method, because this is an informational message. And in that, we can then pass in some information, a message, preferably including the city ID. This type of syntax is also new to C#6. If you haven't encountered it before, this is called string interpolation, a less verbose way to construct strings. By surrounding parameter names that are in scope with curly brackets, they will be replaced by their actual values when the string is constructed. Let's give this a try. Let's try getting the points of interest for the city that doesn't exist. The city with ID 5, for example. We get back a 404 not found. So far so good. And because we added that logger statement, this should also result in a message being logged. Let's have a look at the debug output window. And if we look here, we see our message. We also see other messages being logged. This is logging output from the framework services themselves. Logging informational messages can help you find the cause of an error. But what we really want to log, always, are exceptions. So let's surround our code with a try-catch statement and log that exception. As it's an exception, we'll want this to have the critical level, so we'll use the log critical method, passing in a message and the exception itself. There's one more thing we have to think about. We learned in the status code demo that unhandled exceptions will return a 500 internal server error. But now we're handling the exception, be it simply by logging it, because we're not gonna throw it again. So we must return that 500 internal server error manually. And for that, we can use the status code method, passing in the status code. Optionally, a message can be provided. Be careful with this though. This information will go to the consumer of the API. And you do not want to expose implementation details to those consumers. So don't write out a stack trace or anything like that. What often happens is that the exception message is returned through x.message, but even that potentially exposes implementation details. We have already logged the full exception, so we have all the information we need. There's no need to return that to the consumer. A simple message is sufficient. To see if this works, we'll throw an exception. And let's give that a try. Let's try that request again. What we get back now is our 500 internal server error, including the message we passed into the status code method. And now let's have a look at the debug output window. And there we go, our critical exception has been logged. Logging to the debug output window is convenient during development, but in a production environment it's not sufficient. We'll want to log to a persistent store, like the event log, or a database, or a file. Let's see what we can do in the next demo. In this demo, we'll look into how we can log to a file. ASP.NET Core does not contain a built-in logger to a database or a file. It does contain one for logging to the event log, but as at the beginning of the course we chose to develop for cross-platform, that one isn't available, as the event log is a Windows concept. So how do we log to, for example, a file? Well, the built-in logging system was built in a way that allows third-party providers to easily integrate with it. We're currently at the GitHub page for ASP.NET's logging component. Let's scroll down a bit. If you look down here, at the moment of recording, there are already different providers available. Some of these allow logging to a file, like nlog. Others log to online services, like Logger. Configuration of the logger provider depends on the provider itself. But the way to integrate an external provider into ASP.NET Core's logging system is the same across all of these. It would lead us a bit too far to look into all these providers, but as the integration part is the same, it should be sufficient to look into one of them. So let's choose one that's quite popular in the .NET world, nlog. Back to our solution. The first thing to do is add the NuGet package for nlog. So let's open the NuGet dialog. And let's look for nlog.extensions.logging. Now, at the moment of recording, the most recent version is 1.00 RTM Alpha 4. And that's a pre-release version. So we have to make sure we check include pre-release. And the first one here, that's the one we need. So let's install that. And there we go. Then we'll have to configure nlog. By default, it looks for an nlog.config file in the root folder. So let's add that. We choose to add an empty text file and we name it nlog.config. In this file we'll want to configure nlog, so it logs messages to a file. This is not at all ASP.NET Core related, it's nlog related. So let me paste that in. For the demo, we'll keep it simple. What this configuration does is tell nlog to log anything with level info or higher to a file named nlog, the short date, and .log. Nlog, just as most third-party loggers, has a lot more options. You can configure it to log to different files or targets, you can tell it exactly what to log, and so on. All that info can be found at nlogproject.org if you want to have a look. But that would lead us too far for this demo. We're looking into the principle of using a third-party logging provider to log to a file using the ASP.NET Core logging system. So this is already it for the provider-dependent configuration. Now on to integration. Let's open the startup class. We need to tell the logger factory to use this provider. And that's the part that's the same across providers. There's an add provider method on the logger factory we can use for this. We remember that from the previous demo. This expects an iLogger provider implementing instance. In the case of nlog, that's an instance of nlog.extensions.logging.nlog provider. But there's an easier way. Most of these logging providers include a shortcut extension method, so we don't have to directly call add provider. In case of nlog, that's called add nlog. We'll require a using statement using nlog.extensions.logging, and that should be it. The nice part about the fact that these third-party providers integrate with the built-in logging system is that we don't have to change any other parts of our code. We already have the code to log in the points of interest controller. That same code will keep on working, now also using the extra provider to log to. Let's give that a try by requesting the points of interest for the city again, which will throw an exception. Let's send that request. As expected, we get back our 500 internal server error. In the debug output window, we still see the critical exception we logged. And now let's look at the root directory of our application. A new file has been created with today's date. Let's open that. And here we find everything that's been logged with level info or higher, including the critical information as we wrote it out. And with that, we know how to use an external logging provider. Let's get rid of that exception we're throwing, as that was for demo purposes only. We now know how to use a built-in service, but we can also create our own services. Let's have a look at that. In this demo, we're going to create a service that sends mail to a certain address whenever a point of interest for a city is deleted. Deleting something has quite an impact on consumers of our API. All of a sudden, they have access to less information. And that sounds like something we, as developers or administrators of the API, would want to be notified about. A mail service sounds perfect for that. Mind you, I don't have a mail server set up here, so we won't actually send the mail. The point of the sample is to look into how we can create our own custom services and use them. Let's start by creating a folder, Services, and let's add a new class to it, Local Mail Service. We'll need at least two fields here, a to and a from address. Let's add those and give them some dummy values. We'll add one method to this class, send, in which we'll mimic sending a mail. Let's say we wanted to accept two parameters, the subject and the message. And as far as implementation goes, we'll mimic sending a mail by writing out the information to the debug window. And that's our mail service. Now we have to register this with a container, so we can inject it using the built-in dependency injection system on to the configure services method on the startup class. When we look at the methods we have on services, our container, there's three that are of importance and allow us to register custom services: add transient, add scoped, and add singleton. These refer to the lifetime of these services. Transient lifetime services are created each time they are requested. This lifetime works best for lightweight, stateless services. Scoped lifetime services are created once per request. And singleton lifetime services are created the first time they are requested, or if you specify an instance when configured services is run. Every subsequent request will use the same instance. Our mail service, well, that's lightweight and stateless, so we'll use a transient lifetime. We pass in our type, and from this moment on, an instance can be injected. We want to inject this in our points of interest controller, because we want to send a mail when a point of interest is deleted. Let's open that controller and inject it using constructor injection, just as we did for the logger service. So we'll add a field to hold the instance and set that field to the injected instance in the constructor. Then, in the delete action, we'll call send on this instance. That's it. Let's set a breakpoint here and give this a try. Let's send the delete request to a point of interest. We hit our breakpoint. Let's continue. And let's have a look at the debug output. And there we go, our mail, or at least the way we mimic it, has been sent. Okay, so now we know how to create a custom service, register it and inject it. But this doesn't really drive one of the points of using dependency injection home. And that point was that it delegates the function of selecting a concrete implementation type for the controller's dependencies. In this case, that's the mail service to an external component. Let's open configure services again. We've registered a concrete type, local mail service. That will make it hard to work with a testing service in a different environment. Let's improve on this. Back to our local mail service class. We're going to create an iMail service interface with that send method. So let's add a new interface. And let's make sure it contains that send method. Then we'll make sure our mail service implements that interface. So now we've got a contract, the interface, and an implementation. The idea is that we're going to let the container provide us with different implementations of iMail service. So we'll need another implementation. We've already got a local mail service. Let's add a cloud mail service. We'll add a new class, name it Cloud Mail Service, and have it implement iMail service. I'm going to copy over the implementation from our local mail service and make one change. Change local mail service to cloud mail service. Okay, we've got two different implementations now. Let's open the configure services method again. There's an overload we can use for add transient. Instead of only providing the concrete implementation, we can provide the interface, iMail service, and then the implementation. We've now essentially told the container that whenever we inject an iMail service in our code, we want it to provide us with an instance of local mail service. So let's change the constructor injection in our points of interest controller so we request an iMail service. And that's it. But the thing is, if we run this now, our result will be exactly the same as before, as we've told our container to provide us with a concrete local mail service implementation. How can we differentiate between that one and cloud mail service? Well, back to configure services. One way of doing this is by using compiler directives. A compiler directive tells the compiler to omit or include certain pieces of code on compile, depending on the symbol used. If we're running a debug build, the debug symbol is automatically defined. So we can write code that states that if the debug symbol is active, we'll want the container to provide us with a local mail service instance. And otherwise, we want it to provide us with a cloud mail service instance. We're currently on debug, so the registration for cloud mail service is grayed out. And if we change the build to release, the local mail service registration is grayed out. So, if we build this, an instance of Cloud Mail Service will be provided. The local bug, so the local mail service instance, so well, depending on the symbol used. If we're running a debug build, the container to provide us with a local mail service for Cloud Mail Service is grayed out. And if we change the build to release, the local mail service registration is grayed out. So, if we build this, an instance of Cloud Mail Service will be provided. And that makes sense. We've got a local mail service, probably to be used during development. And that Cloud Mail Service, well, that's probably something we want to do when rolling out, so when we provide a release build. And let's give this a try. I'm afraid we'll have to put this back to debug, because, well, we're writing out statements using debug.writeLine, so we wouldn't see anything with a release build. But the principle should be clear. From the IDE, we could see that another piece of code would be compiled when we change the configuration. Let's try that delete request again. And that looks okay. Let's have a look at the debug output window. And we can see that the local mail service was used as we're running a debug build. But there's something else. That address we sent that mail to. Well, we don't want to hard code that. We want it to be in a configuration file. And it also makes sense to make this different depending on the environment we're in. If we're still working on the code and if we're testing it, we want this address to be different than when we're in staging or production. That's what we'll cover next, working with configuration files.